Hi, this is Dr. Kolkran. I will be teaching Physics 1 course this semester. And let me talk about the main textbook. There are many textbooks, but this is going to be your main textbook. It's Physics for Scientists and Engineers with Modern Physics, and its authors are Survey and Hewitt. And this is the publishing company of the book. It's Engage Learning. It's the night edition I will use for solving problems. The first chapter is, by the way, your physics course code is PHY 101. This is your course code, and Physics 1 is the title of the course. Okay, so we will start with the first chapter and first unit, which is about the measurements. And let me write down over here the measurements and units. Okay, so physics is an experimental science, so that means without measurements there is nothing to do with physics. So first of all, physics deals with physical quantities. So let me talk about the physical quantities. Physical quantities. And what are physical quantities? And let me give some examples like length, or speed, or time, or force. These are all physical quantities. And if you're talking about a physical quantity, it must be measured. Okay, if any physical quantity must be measured, you must be able to measure if you're talking about a physical quantity. So what is measurements? Then, for example, let's talk about the length of this whiteboard. And if you grab a ruler like this, you can simply measure the length of this whiteboard, which is about somewhere between 13 and 14 centimeters, closer to 14 centimeters, let's say 13.7 or so centimeters, right? So what I've done over here is I just measured the length of this whiteboard, but I just took a device which is a ruler, and I refer to this ruler for measuring the length of this board. But is this standard? Yes, this is standard, because every centimetric ruler will measure the same value for this. I mean, that means all rulers are standardized, but what is this reference for every ruler or every measuring tape? There is one standard thing which has the length of 1 meter, which is kept at somewhere like I think it's in France, Paris. It kept there as the reference to be referenced as a 1 meter for all rulers and measuring tapes. So there's always a reference, and we just compare the length of any thing that we want to measure as reference to that. It's standard. Okay, every centimetric ruler will show the same, or will give the same value for this. So it needs to be a standard device. So this is a measurement, basically. I mean, just like length, right? For example, there are some standards for force measurements, weight measurements, right? Because if you're using like maybe a scale, every other scale or electronic scale will show the same weight for you, and they need to be standardized in terms of kilograms, etc. But force is a different unit. So weight is a unit of mass. And let's talk about other measuring other physical quantities like energy, work. Both have the same unit. you will see. And what else? Maybe momentum, right? I can, give many physical quantities, and they can be measured by suitable devices or instruments, etc. Distance, for example, has the same unit with the length, or also displacement has the same unit with this distance, displacement. I will talk about the definition of all these, because we have to define every physical quantity in a standard way. So what else is that, see, there are many physical quantities. I can name over here maybe hundreds of them, but in mechanics there are only 3 fundamental quantities. We talk about, let me talk about fundamental quantities. Fundamental quantities. Okay, quantities. So what I mean by fundamental quantities, if you get these fundamental quantities, every other physical quantity will be able to expressed by some combination of these fundamental quantities. And what are they? There are 3 fundamental quantities in mechanics, and the first one is length. The second one is, let's say, mass, and the third one is time. Well, it's very interesting that all of these quantities, length, force, mass, weight, energy, work, momentum, displacement, all of these quantities, let's add also the acceleration, all of these quantities, physical quantities, can be able to expressed by the combination of these 3 fundamental quantities. Okay, they are by themselves and they cannot be expressed by any other quantities. They're legitimate. They're very well-defined quantities, physical quantities. And every other quantity in physics other than these are called derived quantities. For example, speed. Let's say speed. Speed is a physical quantity, and it's being about how fast some objects are moving. It is a derived quantity because its unit is usually when we are talking about the unit for a unit of a physical quantity, we take a square bracket, and this unit of the speed is equivalent to length divided by time, because the speed is about distance, and also it's about time to take this distance or travel path. So you see, the speed is just length divided by time. Let me also give some short way of writing this. Let's take the capital L as to be length, capital M to be mass, and capital T to be time. Well, these are universal units, okay? Universal fundamental quantities. Well, when it comes to how to measure the length, well, if you're using, for example, a ruler, a centimetric ruler, that means how you measure length. This is a length measuring device. How you measure length is, millimeters or centimeters. This is centimetric ruler. So the unit I'm using for this ruler is, let's say, millimeter, okay? And if you have a scale that measures the masses in kilograms, then the unit for this particular mass measurement of your device is in kilograms. Well, if you're measuring time in units of seconds, then you just define a unit system now. If you pick up how you measure length and how you measure mass and how you measure time, if you set these to these scales, then what you have done is just you build yourself a unit system. For example, let me talk about a very special unit system. If you measure length in meters, If you measure mass in kilograms and if you measure time in seconds, then that means you are using SI unit system. Okay. S refers to standard system, international standard unit system, so SI unit system for sure. But you might measure length not in meters but in centimeters. You may measure mass not in kilograms but in grams. You may measure time in seconds. Then you are using a different unit system, and it's called CGS unit system. Okay, because C refers to centimeters, the length measurement to be in centimeters. G refers to gram. You're measuring masses in units of grams, and you're measuring time in seconds. So CGS system, sometimes it's called the Gaussian or Gaussian. There's a different name for it. Gaussian unit system. Okay. So there are many other unit systems. I will talk about these unit systems. For example, speed, the unit for speed in SI unit system is nothing but meter per second. Okay. Or in longer way of writing meter divided by seconds. Okay. For example, the unit for force in SI unit system is kilogram meter divided by second square, or in universal way, M, capital M because capital M refers to mass measurement, and capital L because it measures meters, and divided by T, capital T square. So this is the universal unit for force measurements, M times L divided by T. So you see, to measure force, you have to use all of these three fundamental units. And in SI unit system, it is kilogram meter divided by second square, and this has a special name. 1 kilogram meter per second square is equivalent to 1 Newton, and we usually denote this capital N, or let's say right in Newton after the great physicist Sir Isaac Newton. So, force is a derived unit system, and speed is a derived physical quantity, because they are expressed by some combination of these three fundamental units. But length itself, or mass itself, or time itself can only be expressed by themselves, so they are fundamental. Okay. All right. So let me talk about three of these special unit systems. Let me erase this. Or let's use a different page. Okay. All right. So I told you that I will give you three mostly used unit systems, three of them. There are many different unit systems, but I will only talk about three of them. Let me write down the universal units for length, for mass, and time over here. And CGS is one unit system, or Gaussian. And SI unit system, and US, United States customary unit system. So all these columns are specific unit system. There are three of them over here. Let me write, for measuring length in CGS unit system, we use centimeters, cm in short. We use grams for measuring masses, and we use seconds for measuring time in CGS unit system, or Gaussian unit system. So centimeters, grams, and seconds. In SI unit system, we use meter, in short, small m. We use kilogram, and we use again second for measuring time. In US customer unit system, we use foot to measure lengths, and 1 foot is equivalent to 30.48 centimeters. So what I have done over here, in fact, I just converted the foot into centimeters. Okay, I converted the US customary length to CGS length. Okay, and slug is the unit for mass in US customer system, and 1 slug is equivalent to 14.593 kilograms. So again, over here I just converted the US customary mass measurement mass unit into SI mass unit, okay, because 1 slug is this much kilograms. And for time, again, US customary use the same seconds for time measurement. Okay, so these are mostly used, most frequently used unit systems, and I also have given some conversion, okay, over here. So this completes about the measurements in physics, the physical quantities, the fundamental physical quantities, and some unit systems in short.